Dear students, today we'll see our next topic in applications of electronic engineering, and that will be what are loudspeakers. So in this we will see what do we mean by loudspeaker, then what is a basic loudspeaker, and then what do we mean by a crystal loudspeaker. And then we will see a definition of woofer and tweeters. So let's start to see what is a loudspeaker. So as we know, loudspeaker is an electroacoustic transducer. It is a transducer which will convert electrical audio signal into a corresponding sound signal. This is the basic definition of loudspeaker. So a loudspeaker is an electroacoustic transducer, a device which converts an electrical audio signal, that is electrical energy, into a corresponding sound energy. So electrical energy will be converted into sound. Loudspeakers work by converting the electrical energy into mechanical energy, that is motion. Okay, so specifically if you see, the conversion of electrical energy will be into mechanical energy. The mechanical energy compresses air and converts the motion into sound energy or sound pressure level. So it is like electrical energy is converted to mechanical energy and mechanical energy is converted to sound energy. So if you see the basic idea of how a loudspeaker works, okay, so in that you can see here you are having a magnet. So here you can see you are having a magnet. Now this magnet is going to have its own permanent magnet area. So here also you can see magnet. Say for example, this is North Pole, this is South Pole. Okay, so magnetic lines of force will be from north to south, and it will have a permanent magnetic field. And in that permanent magnetic field, you are going to place voice coil. Here you can see voice coil. Okay, so you are going to place voice coil. Now these are the voice coils which are placed in the permanent magnetic field. Now in those voice coils, we are going to send the electrical signal, that is the electric current will flow through that voice coils. Once the electric current flows through these voice coils, it will develop its own electromagnetic field, which will be varying as the current is varying, and the current is varying as the information is varying. Okay, so that varying electromagnetic field will interact with the permanent magnetic field, and the coil starts aligning itself according to the polarities, that is the north-south points. Then in that alignment, the coil gives a freedom of vibration, and that vibration is connected to a diaphragm out. This is a diaphragm. Okay, this is a diaphragm, and that vibration, when it is transferred to the diaphragm will vibrate. It will produce sound, and that sound waves will come as output. These are sound waves. Okay, this is what happens in a loudspeaker. If you see this diagram in detail, then you can see that how does a basic loudspeaker work. So here you can see that there is a magnet. So magnet is there, and in that magnetic field a voice coil is placed. Okay, so here you can see a magnet. So this is a magnet, this is magnet, this is a magnet, this is magnet. Okay, so in that you are going to place a voice coil. This is a voice coil. Okay, and then you are going to input a signal here. That signal will go to the voice coil, and the voice coil will develop its own electric field. That electric field will interact with the permanent magnetic field. So this electromagnetic field and the permanent magnetic field will interact with each other, and the coil starts aligning, and then in that alignment a vibration is produced, which is transferred to the diaphragm, and the diaphragm will start vibrating, and it will produce sound. it will produce sound waves. This is what happens in a basic loudspeaker. So in loudspeaker, a current is sent through the voice coil, which produces an electric field that interacts with the magnetic field of the permanent magnet attached to the speaker. So when the interaction of the two magnetic field, one is electric field, electric magnetic field, which is called electromagnetic field, and the field which is given by the permanent magnet, these both fields will interact, and the movable point, which is the coil, will start aligning itself according to the field movement, because the movable coil will be having an electromagnet which is varying, because the current flowing through it is varying, because the information is varying. Okay, so that movement of the electric coil, that will be passed, that will be transferred to the diaphragm, and the diaphragm also starts vibrating, and that vibration is taken as output sound. That is what happens in a basic loudspeaker. As an audio signal is sent through the voice coil and the musical waveform moves up and down, the voice coil is attracted and repelled by the permanent magnet. This is what happens. This makes the cone that the voice coil is attached to move back and forth. The back and forth motion creates pressure waves in the air that we perceive as sound waves. So this is how your electrical signal is converted to sound energy. Now if you see the idea of crystal loudspeaker, okay, so in a crystal loudspeaker, here you can see the input is audio frequency output voltage. Okay, so here you can see the input is audio frequency output voltage. Okay, so this is what input is, audio frequency output voltage. So you can show it like this. Okay, now that voltage is stepped down, okay, by a output transformer and given to a crystal here, given to a crystal via electrodes. This is your electrodes and this is the crystal given to the crystal. Now this crystal will be a piezoelectric crystal like your Rochelle salt. Okay, and this crystal, we know that the principle of piezoelectric says that whenever a voltage is applied across its two ends, then it will start vibrations, it will start mechanical vibrations. Now those mechanical vibrations, if you connect to a diaphragm here, diaphragm, and that diaphragm gives you a sound output because of vibration, then you can say that the electrical input has been converted into sound energy. Okay, now in this way we have converted the electrical energy into sound energy in the crystal loudspeaker. Okay. Then we'll see what is a woofer. A woofer is a speaker designed for low frequency sounds. Okay, and if you see what is a tweeter, tweeter is a speaker designed for high frequency sounds. So for low frequency, it is required that you require a bigger diaphragm, bigger diameter diaphragm, a large diameter, which is loosely connected, so that for any input of low frequency, it can vibrate. For a tweeter, it is the other way around. It is working for high frequency. So the diameter of the diaphragm for tweeter will be small one, and it will be tightly intacted with the mechanism over there. And so whenever a frequency passes through it, it will give a fine vibration. A woofer or bass speaker is a technical term for a loudspeaker driver designed to produce low frequency sounds, typically from 50 Hz to 1000 Hz. So this is how you can see a woofer can look like. So these are some pictures of woofers. A tweeter or a treble speaker is a special type of loudspeaker, usually dome, inverse dome or a horn type, that is designed to produce high audio frequencies are typically from around 2 kilohertz to 20 kilohertz, generally considered to be the upper limit of human hearing because we are speaking about the high frequency. Special tweeters can deliver high frequencies up to 100 kilohertz. The name is derived from the high pitched sounds made by some birds, which can be called as tweets. So the name is tweeter. So this you can see a type of a tweeter is shown over here. So the same function, the first one is your magnet. This can be your magnet. Okay, what you shown here. Okay, this can be your voice coil. Okay, this can be a voice coil. This can be a membrane on that. This can be a membrane on that. And here on top you can have the diaphragm which can move, okay, which can vibrate and produce sound, and the sound can come out like this. Okay, so this is how a tweeter is looked like. Now here the important thing what to know was the diameter in case of woofer diaphragm was from 8-inch to 12-inch, and the diameter for the tweeter diaphragm was will be around 1 inch, so it will be small in size. Okay, thank you, students.